All right, so man, uh, the guy who runs the Fab Lab is not here this summer, and everything has fallen apart since he left. So I'm really trying to get your parts 3D printed, but our main 3D printer had a power failure, and now our backup 3D printer is having a problem. I ordered the parts that I think I need, so hopefully I can get those to you. But I was hoping to have them today, and I don't. So the the 3D printed stuff is kind of on hold, but I'll get that as soon as I can. Um, and then we're going to keep going with the robotics stuff today. We're going to together do a demo, like go through sort of a tutorial where I'm going to show how to use a sensor, and then based on those sensor readings, do some kind of action. And that's kind of the heart of any robotics project. So you'll sort of see how that works. In doing that, I'm also going to introduce transistors, which are going to be important for you. So we'll try to finish all that today. And then once we're done with that, all there's going to be left is working on your robotics projects. And so we'll have time in class the rest of the time just to finish robotics projects and stuff. Before I get into the tutorial, does anyone have any questions about the homework? Okay. So for the homework, there was some stuff about parallel resistors and some stuff about Arduino and some a project of finding an assignment where you just have to find some information out about some of the sensors that are available. And so the idea is, like, if you keep those sensors in mind, it can really help you decide on your robot project because you know what kind of values you can find. All right. So the first thing we're going to do, I gave you the code last time, and I just sort of wrote it out and described what it does. And now we're going to go through it and actually program this thing up. We're going to hook up an ultrasonic sensor, which is used to measure distances to objects. And we're going to have it every 1/10 of a second read a distance to something you put in front of it, and then print that distance up onto the computer screen. Okay, so that's our objective. To wire it up, we're using, there's no reason that we have to do this, but I happen to choose pin 7 to be on the ultrasonic sensor, the pin that sends out the signal. And then pin 6 is the echo, which reads when it comes back. So we're going to be using the HC-S04 ultrasonic sensor. And the reason I'm using this sensor is it reads distances, and this is just the one that people use the most. Although, you might need a different set of sensors in your project. And it looks like this. I drew this picture last time. If you're looking at it from the front, it has the two eyes that both send out the ultrasonic signal and read when they bounce back. And then it has the 4 pins. And this one is VCC, which needs to be hooked up to a +5 volts. That's the power. And then on the other end, you can't have power without a difference in electric potential. So this is the ground. And then the other two are the trigger. That sends out the pulse. And the echo, that's what receives the pulse. And to hook this up, we're going to have our Arduino And over here is the plus 5 volts. And next to it is the ground. And then down here on the other side, we have our pin 7 and our pin 6. And these are just in these rows of pins. You just have to find the right ones. And we're going to use the breadboard. So here is the positive power rail and the negative power rail. And then here are the rows that are connected. We're going to connect the plus 5 volts to the positive power rail. And we're going to connect the ground to the negative power rail. It doesn't matter where you connect those along that line. And now that just means that anything we touch to the red power rail is going to be at plus 5 volts compared to the ground. Anything we connect to the black, the one next to it, is going to be at 0, is going to be at the ground. And then we're going to hook up the ultrasonic sensor like this. And so we want the VCC terminal of the ultrasonic sensor to be connected to the positive power rail. We want the ground to be connected to the ground power rail. And then we want 7 is going to be our trigger, so we want that connected to the trigger. And then 6 is going to be our echo, so we want that connected to the echo. So there, this is all wired up. And I think there's an online environment for the Arduino. Let's try that. Otherwise, I know it's installed on all these computers, but let's see if we can just get it straight off of our laptops. Okay, Arduino, blah, 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 Arduino. Okay, Cloud Editor. You have to log in and stuff. Let's see how long that takes. home. And where did you make an account? Cloud? Is that what you said? Oh. Okay. Looks like I already have an account, which makes sense. Okay. So if you create an account, then, and you have something like this. Okay. Well, let's just take a minute and everybody can make an account right now, okay? It'll be good to have on your computer. But we're going to talk about the one that we have a million of, and that is the TIP 120 transistor. Transistors are widely, I don't know if universally, but widely considered the most important invention of the 20th century. And transistors can always do two things. And that's true of any transistors. We have this specific one, but transistors always can do two things. And those are, they can work as amplifiers. And they can work as switches. And primarily, like in computing applications, which is why transistors are so important, the key thing that transistors do is they work as switches. We're not going to deal with their ability to amplify signals. We're only going to deal with the switch thing. And the reason that switches are using transistors as switches is going to be important to us is because in order to do robotics, a lot of times you need higher currents than the pins on this board can supply. So like you can imagine, we might have a robot where if an object got within 5 centimeters of this thing, we would want to change some motion of a motor or something, you know. But the way we would do that is in our program, we would say, now we have this output pin 5 maybe or something that we would turn high to turn on this motor. The problem is the output pins on the Arduino board can't produce enough current to power a motor, okay? But what they can do is produce enough current to turn a switch on and off in a transistor. And then the transistor is what actually allows the higher current to flow. If you look at the transistors from the front, these TIP 120 transistors, you have a bunch in your kits. They are these guys. The circle on the top, by the way, is for hooking up heat sinks because they can heat up if you run too much current through them for too long. And so if you look at it from the front where you can see that black plastic piece, they look like this. This isn't what all transistors look like. This is just this specific one. But you have this black section. You can see the metal section with the heat sink hole. And then you have the 3 output pins, the 3 terminals. And these are called the base, the collector, and the emitter. And I don't find those to be very descriptive words, but they've already been named, so I don't get to name them. And this is the way it works. When you send a small current in the base and out the emitter, it allows a bigger current to flow in the collector and out the emitter. How big can this big current be, and how big does the small current have to be? This should be less than about 20 milliamps, which is great because our output pins, our pins on our Arduino board, can produce that much current. And then this bigger current can be anywhere up to, at the most, about 2 amps. But 2 amps is a lot of current. Here's the way it'll work. Our Arduino output pin is going to go to a 1000 ohm resistor. And then from the 1000 ohm resistor, it goes to the base. And the ground is going to be connected to the emitter. So the way it works then is when you program your Arduino output pin to be high, a small current flows through the base, into the base, and out the emitter. And that closes the circuit, or allows electricity to flow in a circuit that goes in the collector and out the emitter. For using these transistors in schematics, it looks like this. And it all has a circle around it. And so those are the 3 terminals of the transistor. This one is the base. This one is the collector. And this one is the emitter. Okay, so I'm going to do 2 examples. They're really the only 2 examples you need. The first one is using a transistor to switch on, or just to switch on and off, a high current device that's not a motor. Okay, so I'm going to treat pin 9 as my output pin. And instead of, I'm not going to draw it with the breadboard and everything. You can use the breadboard to make these connections. But I'm going to go from so I'm going to have my transistor over here. And you can remember going from left to right, base, collector, emitter, because it's in alphabetical order, by the way. So we're going to go, if this is the Arduino, and this is pin 9, and over here, this is the ground. I'm going to go from pin 9 through a resistor, and this is 1,000 ohms. The 10,000 ohm would work fine too, by the way, but don't use smaller than those. And then I'm going to go to the base. Then I want the ground to be connected to the emitter, so that's easy. And then the last thing I want is, now I'm going to have a circuit, just a simple circuit powering my device, but part of that circuit has to include the current going in the collector and out the emitter. So I'm going to have, I'll put a battery over here. You know, this could be our high power battery, 12 volts or whatever it is. And it's going to go, I'm going to go from the positive to the device. And then from the device to the collector. And then I need the negative of my battery to be the same electric potential as the ground. So I'm just going to connect this to the ground. So the way this works is, if you have a connection between the collector and the emitter, current is going to go from the positive through the device here. It's going to go around this circuit and power this thing. If you don't have a connection between the collector and the emitter, then it breaks that circuit and no electricity can flow through that circuit. And so the device turns off. Yeah.
What's the difference?
It doesn't matter what it is. All that matters is that it's not a motor yet. So there's one change we have to make when it's a motor. Okay. And the reason we have to make one change is that there's magnetism going on in motors that can damage these components. Okay. So, and so now if you program pin 9 to be high, then a current goes here, connects the collector to the emitter, and that allows this to go. So when you program pin 9 high, this device turns on, whatever device it is. When you program pin 9 low, no current flows through here and through the emitter. It opens this circuit and no current can flow in that big thing. So that's using this transistor as a switch. Okay, so I'm going to do it one more time, but this time it's going to be with a motor. And I'm just going to draw all the same stuff again because it can't hurt to redraw stuff. So here's the transistor. Base collector emitter. And here is the Arduino. I'm going to use, so this is for, this is a switch for a motor. Okay. So here's our pin 9. Here's our ground. Here is our 1000 ohm resistor. So I'm going to go from pin 9 through the resistor and to the base. And I'm going to go from the emitter to the ground. Though that's how that always works, no matter what the device is. And now I'm going to have the battery or whatever the power source is that's powering this motor. 12 volts is just the stand-in here for a powerful battery. And this time I'm going to draw the motor. So motor looks something like this. So when you turn this on, it turns this shaft. And I'm going to call this the positive. This is the positive terminal of the motor. This is the negative terminal. And this is going to start out the same way it does for any other device. We're going to go from the positive to the positive of the motor, out the negative of the motor to the collector, and then the negative of the battery is connected to the ground. So far, it's no different than any other device. The one difference is when you turn off a motor, there is potential energy built up in magnetism in the motor. And when you turn it off, it causes a surge in electricity. To protect the parts from this surge in electricity, we're going to put a diode in the reverse direction of the motor. So a diode looks like this. It has a white stripe on one side like this. And the meaning here is this current is allowed to flow in through a diode toward, if you think of that white stripe as like an arrow kind of, it can flow in the direction of the arrow, but it can't flow opposite the direction of the arrow. So it can flow toward the white stripe, but not starting at the white stripe. And so we're going to hook this up in the opposite direction of the electricity going through the motor. So we'll go here and here. Okay, and that allows, when you have this surge of electricity, that allows this electricity to be dissipated without harming the sensitive electronics. So this diode is the only difference between dealing with a motor and dealing with anything else. You don't need this when you're dealing with other stuff, but because of the magnetism in the motor, you need it when you're using a motor. Any questions about that? Okay, so the next thing we're going to do, I don't know if we'll get through this today, but we're going to use a transistor and connect a motor to this Arduino board so that when your hand gets within whatever, 5 centimeters or something, the motor turns on. And when you move your hand away, the motor turns off. Okay. All right, so how are we going to do that? Oh, I guess, why don't I put a schematic of this in here? So here's a schematic of a transistor switching a motor. Okay, so we're going to go from our voltage source, which is going to be pin 9. And we're going to go through a 1,000 ohm resistor. And then we're going to connect to the base of the transistor. Okay. So now we have pin 9 connected through a resistor to the base. The one with the arrow on it is the emitter, and all we're doing there is connecting that to the ground. So we'll put a ground here. And now we're going to go from our big battery. So let's say this is our 12-volt battery. We're going to go through the motor. And I don't have a symbol for motor. We'll just write it like this. And it'll connect there. And we'll have a diode going the opposite direction from the motor. So the diode will go like, we can connect this here. Allowing electricity to flow the opposite direction that it flows through the motor. And then the last step is we have to make the negative of the battery have the same electric potential as the ground. So we'll connect the negative of the battery to the ground. Okay. If this was a different electrical device besides a motor, the only difference is there'd be no diode in here. Okay. A lot of the homework for today is just going to be kind of reproducing this stuff. But you'll understand it a lot better if you try to think through it yourself and then go look at the notes and use that, but try to do it without looking at the notes, and then look at the notes and then try again to do it without looking at it. And you'll remember how to do it a lot faster. Okay, so now the last step of our program, I think we're not going to get to wiring this today, but let's just talk about the programming at least. So the last step in our example Arduino program. So after the, let's see, I have it here. So in the loop, after we go through all this stuff, we have the distance in this variable distance. So now we're going to want to say if the distance is less than some amount, let's make that amount 5. So this is going to be after we have calculated distance in the loop. We're going to say if distance is less than 5.0, and this distance is measured in centimeters, then I'm going to use the squiggly brackets. You don't have to use them because there's only one command here, but if you do this, then digital write pin 5 high, and then semicolon. And that's the end of this. And in any other case, if you're not within 5 centimeters, we want to write pin 5 low. So we'll say else, and digital write 5 low. This would all work the same without those squiggly brackets. But so now, every time we take that measurement, we're checking to see if it's within that distance that matters to us. If it's less, if you're closer than 5 centimeters, we're going to turn pin 5 high on 5 volts. If we're farther away, then we're going to turn it off. And then that pin 5, we're going to use to switch with the transistor. We're going to use to switch on and off the motor. Okay. There's one more thing we have to do here. In the setup function, so this is in the loop, and in setup, we're going to have to specify now that pin 5 is an output. So we're going to say pin mode 5 is output. Okay, so let's go to, I'm going to go to my editor. And I'm going to make, so pin mode 5 output. Output is anything where you're just specifying, now turn this on, now turn this off, you know. And now here, once we've calculated, we can keep writing these to the screen. It doesn't help or hurt what we're trying to do. So I'm going to leave those in there. These will still just print to the screen. But now I'm going to say it has to be lowercase. If distance is less than 5.0, digital write 5 I. If distance is not less than 5.0, so I can just write that as else, digital write 5 low. So hopefully if we type that in right, all we have to do now is wire this up. And we're going to do it with a motor. And so I guess we'll do that at the start of class next time. It won't take too long. And then you'll have the rest of the time to work on your projects. Part of the assignment for tonight is to get together with your group and start thinking about a project, and there'll be some questions to answer and stuff like that. I'm going to just put everyone's email up on D2L, if that's all right, unless anyone has any objections to that. And you can just contact each other that way. And groups should be 2 or 3 would be best. If it works way better for you to have a group of 4, I guess that's fine too. So, okay, any questions? That's it for today.